Hello everyone, my name is Victor Fuentes and today I'm going to be presenting Tvix store in production, how we use Tvix at Replit. Alright, so first, who am I? My name is Victor Fuentes. I go by VLinkZ on GitHub and on social media. I've been a NixOS user since around 2021. Some work I've done, I ported the Calamaros graphical installer to NixOS. Some of you may have used it. I've also experimented with some other graphical tooling for NixOS, such as like Nix Software Center. It's like a graphical app store. And now I'm working as a platform engineer at Replit. Okay, so what is Replit? Replit's a web application development platform. We have this AI agent that lets you talk in natural language and it creates code for web apps. We also have pretty much a full IDE implemented in the website. And the important thing, how does Replit use Nix? Every user gets a full Linux container, and these containers use Nix for package management. Another cool thing, the AI agent I mentioned can install Nix packages and run them. Okay. So let's talk about what some of you may have heard about local overlay store used at Nix. So in order to have some faster dependency installation, usually when you install dependency, pull stuff from cache.nixos.org. Takes a little while. Since we're serving all these Docker containers, we don't want just so much ingestion into our system. So we have this persistent local Nix store disk. It has a snapshot of pretty much all open source packages from cache.nixos.org for every single NixOS release. So this giant disk gets mounted into our user's Docker container. And in order to still allow them to put their own custom Nix packages, use Nix how they want to, we also overlay a mutable Nix store using overlay.fs, so that's mounted on /nix/store, and then using the experimental local overlay store flag on Nix. This allows us Nix to know like where the metadata is for each of these stores. So the metadata for this read-only persistent disk reads it from there. The metadata for the mutable user files reads it from there. That's great. So this has been working great for us for a while, but as the years have gone by, this persistent disk has continued growing in size and growing in size and growing in size. It reached a maximum of around 20 terabytes. Some of that was not Nix stuff, but a lot of it was. So this was costing us a lot of money, and we needed to find some better solution to this. Another thing I want to note, incremental updates were not as feasible since we do deploy this disk in a number of different regions, and replicating that across the regions was extremely costly, especially when it was 18, 20 terabytes large. So we're looking for a solution that we wanted to keep all the cached Nix store paths in that cache, because users are already linking to them, symlinks, dynamic linking, but also reduce the size of this disk. So the solution we found was using Tvix. So what is Tvix? Tvix is a modular reimplementation of Nix written in Rust. It has a number of different components, and they can be used in different cases, very modular, and the one that we're going to be looking at is the Tvix store. Okay, so what is the Tvix store? Tvix store, let's talk about Tvix CA store first. So Tvix CA store is a content address storage medium. So all the files, directories, blobs, stuff gets stored in a chunk content address format. I'm going to talk about more in a second, but pretty much the Tvix CA store doesn't know anything about Nix. That's just how we store the files inside of it. The Tvix store wraps around this Tvix CA store, and you see this blue path info. That is a linking of, we have this Nix store path. Here's like the hash. How do we go from there into this Tvix CA store land of content address stuff, and how do we get the data from that? Each of these blue nodes can have a number of different backends. So for the blobs, we can have local blob storage on the disk, but we also have features where it can access cloud storage like S3 or GCS. The directory and path info can also be a local REDB database, but it can also be like a cloud big table. Okay, so let's talk about, so this Tvix store exposes this binary command. So Tvix store daemon runs this store daemon, and then other instances of Tvix can connect to that. Tvix store mount exposes the NIX paths through fuse. So one is content address is just a bunch of blobs, you can't really do anything with it. If we run this Tvix store mount, it exposes these files just as the NIX store paths that we're used to. Tvix store copy allows us to ingest local store paths into the Tvix store. And while it's not technically part of Tvix store, NARBridge exposes Tvix store as a binary cache, just like any regular NIX binary cache. So we can upload files to it, download files from it. But on the back end, it's all this content address deduplicated storage. Okay, so let's go over a little bit more about how this deduplication works. So the Tvix CA store uses Blake3 hashing for content address blob storage. So larger blobs files are split into individual chunks, and then these chunks are content defined. So that means, say I have 2 versions of Chromium, and most of the file or the binary is the same, but a few parts of it are slightly different, then only those parts that are different, those chunks that are different, are stored separately. But everything that's the same is stored within that one chunk, since it's content defined. This is very good for storing a lot of similar data, especially in our use case at Replit. We have snapshots of NIX packages over the years, and a lot of packages don't change all that much. So instead of just having this duplicated over again, why not just store it once and define it? Okay. Another cool feature in Tvix store, this is currently experimental, but store composition allows us to use multiple different backends for each of these nodes at the same time. So say I want a few NIX store paths that are really important to me, and I need to run those fast. I can store those on a local disk, and I still want access to a bunch of other paths not as important. I could store those in the cloud, and then Tvix store knows how to ingest both of these together and serve. So when I'm looking into my Tvix store, I could still see everything, even though some are slower than others. Another cool feature, we can set this up similar to like an LRU cache. So if we say everything is in the cloud, we have this local disk. As we hit store paths, let's just pull that data into our local disk. And that works pretty well. Okay, so let's go into how does Replit use Tvix store, now that I talked about what Tvix store is and what it does. Okay, so this is our old system for managing containers. So we have this purple is a container management VM. So Replit, we have all these containers that we serve to users. This VM manages all those containers, some custom orchestration that we do. This giant NIX cache is mounted into the VM and then mounted onto each of those containers. And then the user files, their project files, and their local NIX store is also mounted into the user container. So how does this change with Tvix? Okay, so this is a diagram of our new layout. So we have all these Tvix blobs, directory info, path info is inside the persistent disk. It's a lot smaller than our previous persistent disk since it's content addressed. We have our container manager VM. This VM is now running Tvix store as a systemd service, and then that's mounting, exposing through Fuse the NIX local store. So we have our blobs directory path info running through the daemon, and then that exposes our NIX local store. And then to the container, this still looks like nothing changed. We're just exposing a similar NIX store, same thing, local overlay store. Works fine. Makes sense. Cool. So that is a lie. That's not how it actually works at all. Kind of. So we had to cheat a little bit since Tvix is still in active development. So for now, I mentioned before the metadata. So NIX stores metadata in like /nix/var. We have this SQLite database, has all the paths. When you do Tvix store mount, it exposes a Fuse file system of the NIX store paths, but it doesn't have any of the metadata there. So in order to do this local overlay store, we still need the metadata. So right now what we're doing is we have the SQLite database that we generated beforehand, shove that into the persistent disk, and then read that in the local overlay store. Kind of hacky, can't do all the modular stuff we want with Tvix with this, but it works, and it's in production right now. Now, in the perfect world, once Tvix finishes some more stuff, the pure Tvix implementation, we would have the Tvix store daemon. The Tvix store mount would still expose all those Fuse paths, but then this piece, the Tvix NIX daemon, exposes a NIX daemon socket. And then we can mount that into the user container and then point the local overlay store to point at that for the metadata. And then it could query that, get all the metadata it needs from the socket, and that metadata is read directly from the Tvix store. So we don't need to do any hacking around with SQLite databases. Okay, so what are some takeaways of what we were able to accomplish? So we were able to compress our Nix cache disk from around 6-ish terabytes of Nix store paths down to around 1.2 terabytes. For us, this reduced our cost for our disk by around 90%, so definitely a big win on our side. Also, incremental updates don't take up as much space, so it's more feasible to roll this out more often. So what's some future work we can do? So using the Tvix Nix daemon, like I mentioned, we could just query the metadata directly from Tvix store. We don't need to have the SQLite database. Now, using store composition, if we have this Nix daemon for the metadata, now we can start using these cloud backends. We could maybe even remove the persistent disk entirely and just have the LRU cache that I mentioned before. So all this is, once the Tvix Nix daemon is ready, we can do all this fun stuff. Okay, so I'm gonna do a quick demo. A lot of people who I've talked to about Tvix know kind of what it is, don't really know how to use it, don't know what to make of it. So let's switch over to the terminal and we'll do a quick demo on how to use this. Okay, cool. So here I have a couple different versions of LibreWolf from some different channels. They all have different versions. So let me Nix copy this. So I'm going to copy this into a local Nix store. So this is similar to what we had on our old persistent disk. We just copy the Nix paths into a local Nix store and then put that on the disk. So let's copy that. Okay, that's copying over. Take a second, not too long because this is all local. Almost done. All right, perfect. So we have Nix store. We have all these store paths in the Nix local store. Let's check the size. Okay, 5.1 gigabytes, a few different versions of LibreWolf. Cool. So I mentioned before there's this NARBridge utility that we can use to turn Tvix into Nix binary cache. So I'm going to run that right now. So now I have a Nix binary cache hosted on my computer, and I can Nix copy stuff into that binary cache. So right now what this is doing, so copying the paths, doing all the chunking, all the deduplication, putting that into these Tvix store files. I'll show you those in a second once this is done. This is going to take a tiny bit longer since it's doing all this chunking. Almost there. And finished. Okay. So all that's copied up. If we look inside this Tvix store directory, what we have, like I mentioned before, we have this path info database, this directory database, and these blobs. And the blobs are just a bunch of little tiny bits. Let's check the size of that. So sh Tvix store. 2.2 gigabytes. Okay. So if we compare those, 2.2 gigabytes compared to the 5.1, that's pretty good. Also, I do want to note that I do have auto store optimization on, so I am saving some disk space on hard links inside the local Nix store. So if you didn't have that, it would be even worse for the Nix store. Now, if we do want to use this for anything, like I mentioned before, we have this Tvix store mount that exposes everything over a fuse file system. So if I look in this mount directory, and there we have all these Nix paths, just like the Nix local store. Great. So, and this is exactly how it works inside of Replit, inside of our backend infrastructure. We're just running this Tvix store mount. Right now we're cheating with the SQLite database, but eventually we won't need to do that. Okay. Great. So I would like to thank my coworkers, Ryan Mulligan and Connor Brewster. They helped me a lot along the way working on this project. I'd also like to thank Florian Klink, Flokey, and all the Tvix contributors, and we're happy that Replit has been able to financially support them on working on this project. Great, so thank you so much. Does anyone have any questions? And also, Replit is hiring. Yes, Thomas. What was that? Last part? Yes. Yes. Yes, so the question was, if we copy into a compressed binary cache format, we could get some benefits from compression, not just from deduping. Yeah. And then we could do comparison with deduplication. Yeah, for sure. Definitely, that's something we could look into. Yes.
The metadata database hack that you've done,
Yes.
does that just support the two-layer store only, or is it necessary for like a simple?
Yeah, so the question is the metadata layer hack that we did, is that just to support the local overlay store or just for anything? So when you use Nix to query any sort of Nix command, it's going to be reading that metadata to see does that store path exist in the store. Even if the file is there, it still wants to know, like, does Nix think it's there? So if we wanted to use like Tvix just directly without any local overlay store, using this Tvix store mount, we would still need some sort of way to query that metadata, be that the hack that I did with SQLite database or using the Nix daemon. Yes.
I assume that then goes into the local mode for that, so it won't do that query next time, right?
Yes, that's
So
so.
the first time it's going to look for a whole bunch of info, so
Yes, so the question was, the first time it's going to look for a lot of our info, and then after that it's going to be cached, so it doesn't need to look at it again. Yeah, that should be the case with, I mean, it just acts like a regular Nix binary cache for using that in our bridge. More questions, comments? Yes.
Do you have any cross-mix version protocol issues, either with SQLite database schema or anything else like that?
So right now, the question was, do we have any issues cross Nix versions with the SQLite schema? So right now in Replit, we just have a pinned version of Nix that we use for everything within the container. So we're able to just account that everyone is using the same version of Nix in this, and we don't really need to worry about it too much. Yeah. All right. Great. Thank you so much, everyone.